All right, so last section before our test, okay? The test is not as hard as the worksheet. If you haven't joined Remind, people, I'm warning you, you should join it. If you don't, you're not going to be as informed as the children who have joined are going to be. Okay? So, let's go, get it. If you by chance have gotten in trouble and have gotten your phone taken away, then tell your parent to join for you. Okay? I'll just usually text them. There were a couple that did that. They joined and their kids joined. And I said, is this so-and-so? And they texted back and said yes. So I was like, okay. So here we go. Solve linear inequalities. What does the word linear mean?
Line.
Okay. And so what kind of x am I going to have? An x to the what power?
1.
Yeah, an x to the first power, because that's what makes a line. An x to the second makes it's a quadratic, that makes a parabola. Okay? An inequality.
That's greater than, less than, greater
Yeah. Yeah, so these are just x, we're just gonna be solving for x, and it's gonna have greater than or less than signs in it. Okay? So we know how to do this, right? You solve an inequality the exact same way that you solve an equation, right? There's only one difference. Does anybody know what it is? There's only one difference. Yes. If you multiply or divide by a negative number, you have to flip the sign. Okay? There's one difference between solving equations and solving inequalities. If you multiply on an inequality by a negative number, multiply or divide, then you have to flip the sign. Now, since that's the only rule, do you think I'm going to test you on it?
Yes.
You can bet on it, people. You can bet on it. All right? I will make it on my test. All right, so here we go. Example 1. I'm going to do 4 problems. And then I'm going to go teach you the new skill. All right, so here's the first one. 5x plus 2 is greater than 12. I'm solving for x. Tell me what to do first.
Minus 2.
Minus 2. What you do to one side, you do to the other. Plus 2 minus 2 cancels out. 5x on the left. Greater than, what's 12 minus 2? 10. Now what do? Divide by 5. Do I have to flip the sign? No, we didn't divide by negative, did we? We just divided by 5. Okay, so I'm going to divide both sides by 5. So x is greater than, what's 10 divided by 5? 2. So there's my answer. Okay? Anybody got a question? All right. Example B. Are you ready? Negative 2x minus 7 less than or equal to 5. Negative 2x minus 7 less than or equal to 5. How about I give you 1 minute and 15 seconds? Go. 1 minute, 15 seconds. You keep working if you're not finished. I'm going to start on mine. So if you're stuck, you can look up here and get it again. All right, so here we go. First thing I did was I added 7 to both sides. Now I'm dividing by negative 2. As soon as I divide by that negative, every bell and whistle in my head should go off. Because what do I have to do? So now is when I'm going to flip the sign. Instead of being a less than or equal to, he is going to become a greater than or equal to. What is 12 divided by negative 2? And if you leave it like this, I'm going to mark it wrong. Does everybody agree? Okay. So here it is. Anybody got a question? All right. So now here's what I want to do. I want to skip about 3 lines. Okay, I want you to skip about 3 lines, and then I want you to draw a line, and we're going to start working some more, but we're going to come back and put some stuff here later. Okay, we're going to come back and put some stuff there. All right, So we're gonna talk about now compound inequalities. Compound inequalities, okay? Now, when I first start telling you stuff about compound inequalities, you're gonna kind of be, what is she talking about? But when we get into it, you'll understand more, okay? So a compound inequality is either going to be an and statement, or it's gonna be an or statement, okay? It's either an and statement or an or statement. It's one or the other. And it depends on what the inequality is. All right? So listen to me. I'm going to now y'all listen. Math is logical. Whatever your first instinctual thing is, that's usually what you should go with. Okay? So I'm going to give you a choice. I'm going to let you decide which one goes with which. All right? And, or. Okay? Your choices are less than and greater. Did you get it? All right. So who goes with or?
Greater.
Yeah. So greater. That's not the way you spell it. It's really greater. Okay. But that tells you if it's a greater than sign. Greater then goes with or. That's an or statement. So what do you need to know about or statements? Well, first of all, they are never, ever written together. They're always going to be written apart. Okay? Let's go ahead and write this next thing down. We didn't do this last class, but I'm going to. We're going to use the word or you can use a U with no tail. Don't put a tail on it, people. It is not a U. It is a symbol that means union. It means or. This is a symbol for or, okay? You're going to have to use it. You're going to write the answer two ways later on. And so in one of the ways you have to use it, and the other way you can or you don't have to. But I use it all the time. That way I don't have to remember which one I'm supposed to use it on. Okay, so let's talk about and statements. And statements are less than. Less than. Okay, so when I see that and, it makes me go, oh, okay. Less than, that's an and statement. Okay? How do you write a less than statement? Well, he is always written together. Yeah, just the opposite. Always written together. Now, when you write him together, my signs, those are my inequality signs, should be the same. In other words, they should look alike. If they do not look alike, if they are not doing the same thing, then they are wrong. Okay? Your signs should be pointing the same way. They cannot be pointing to each other or away from each other. All right, everybody okay? Okay, so here we go. This is a compound. Now, y'all, compound means that there's more than one. Like a compound sentence has two subjects, right? All right. So this one's going to be more than one inequality. So this is what this one's going to look like. -4 less than. Now, let's take for just a second and let's talk about these signs. Because we're not doing the alligator eats the bigger number and all that mess. I don't know why they don't teach it this way when they first teach it, but this is the easiest way to remember it, okay? All right, so how do we read in the United States of America? From left to right, okay? So pretend like you don't, this guy's not even there, okay? And we're gonna read this sign from left to right. When you read it from left to right, what's the first thing you come to? The little end or the big end? Then that's a less than sign. Okay? So easy. Look at this guy up here, okay? This, forget about this mess right here, all right? And we're reading from left to right. When you reading from left to right, is the first thing that you come to a big end or a little end? So that's a greater than sign. Doesn't that make sense? Everybody agree? Y'all know what that is? that was George Washington.
What is that?
A
Yeah,
feather.
it's a porcupine quill,
Oh,
which they used to make pins out of, right? You think that's sharp?
probably.
Dang, why is it so
Very
thick?
sharp. Look. That would hurt,
Oh,
right?
Sharp as that.
That would
Why
hurt.
you just gold it? Why is it so
Yeah.
thick?
Yeah. Alright, so here we go.
Why didn't have that?
-4 is less than 6x minus 10, less than or equal to 14. Okay, so we're gonna solve for x. Here's my x. Now notice this. Notice this. Notice what they said about our signs. The signs should be the same. They should look just alike. Do these two signs look alike? Are they pointing in the same direction?
Yes.
Y'all listen to me. If your signs are pointing at each other or away from each other, they're wrong.
Huh?
If your signs are pointing at each other or away from each other, they're wrong. This is what I'm talking about. If your signs are pointing like this, that's wrong. If your signs are pointing like this, that's wrong. They're either both pointing this way or they're both pointing the other way. This is the best way. But this way's not wrong, but this is the best way. Okay? All right, so here we go. So I'm going to start right here. I'm solving for x. Just look at the middle part and tell me what you need to get rid of first. How do you get rid of a minus 10? Okay, how many sides does this thing have? Oh, say it, Ace.
There's 3.
It has 3 sides. It has a left, a middle, and a right. It's a compound inequality. So instead of having 2 sides, it now has 3 sides. What you do to one, you do to all. So used to, I would do it twice. Now I'm going to have to do it 3 times, okay? So I'm going to add 10 here so that this goes away. But if I add 10 in the middle, I got to add 10 on the left, and I have to add 10 on the right.
That's crazy.
Okay, now this is gone. You're left with 6x in the middle. On the left, what's -4 and 10? On the right, what's 14 and 10? Now what do I do? How many times? Very good. In the middle, they cancel out, and you're left with x.
On the side you can't see.
What's 6 over 6? 1.
I actually put 1.
On the right, 24 over 6. 4.
Oh, no.
Okay? So this is what it says, but this is the way I would read it, and I want you to know why. If I read it this way, do you have any earthly idea what kind of numbers I'm talking about? 1 is less than x, which is less than or equal to 4. When you say that to me, my brain goes, wait, what? What did you just say? Okay, but watch if I say it this way. X is greater than 1 and less than or equal to 4. Now you know that I'm talking about all the numbers between what? 1 and 4. Including 4, but not including 1. Okay? We're going to write some more stuff right there. All right, so let's do an or one. Now, or ones, you know what? You're never going to get these two mixed up when they're written out because the or ones look like this. 3x plus 5 less than or equal to 11, or 5x minus 7 greater than or equal to 23. Okay, so how am I going to tell if this is an and statement or an or statement? People, it says or, okay? It says or, this is an or statement, all right? They're written apart, never written together. Written together, always written together. Do you see what I'm saying? All right, so what do you do here? People, this is just a teacher's way of giving you two problems.
They're pointed together. I mean, like they're facing the.
But that's not true over here, that's
Oh,
only
yeah,
over
yeah,
here.
yeah, yeah, okay.
Okay, so over here, and I'm gonna say this, most of the time, these will be written like that, okay? They won't be the same, most of the time. All right, so over here, tell me what to do, right here. Subtract 5. So now I got 3x is less than or equal to, what's 11 minus 5? Now what do I do? And x must be less than or equal to 2. 6 over 3 is 2.
Or.
Look at my or.
That's crazy.
Or. It's a union symbol. This is proper set symbols. All right, we're going to talk about those in a minute. All right, look up here. What am I going to do first up here? Add 7. So 5x is greater than or equal to 23 and 7 make 30. Divide by 5. And x must be greater than or equal to 6. So x is less than or equal to 2, or x is greater than or equal to 6. All right, anybody got a question? Can y'all solve inequalities? The only thing you have to remember is if you multiply or divide by a negative, you have to flip that sign, right?
Yep.
We did that on this one right here. Okay, so save this piece of paper. We're going to come back to it at the end. Okay, but right now I want to talk about what the new stuff we're going to learn. Okay, so we're going to learn how to write our answers a few different ways. Okay, 2 of the ways you already know, and 2 of the ways you do not know. All right. So one new way is what is called interval notation. Okay, interval notation. Now, interval notation has some little symbols. All right, so let's define all the symbols, and once we define the symbols, then it's really easy. Matter of fact, when you get into your next math class, we do everything in interval notation. Okay, the book wants us to do everything in interval notation, but then, do you know what the book did? It's a college book, and so the book put the answers in proper set notation. All right, so then the kids were like, "Whoa, what does this mean?" And I'm like, that's proper set. Y'all don't know proper set? Used to, you learned proper set in junior high or middle school. Well, now they don't do that anymore. So we learn it in here. All right? So interval notation, here's all the things that you need to know. If on a number line, you go all the way to the right. If you're on a number line and you go all the way to the right,
Yep.
what are you going towards? Yeah. You're going towards positive infinity, or you could call it just infinity. Well, what if you were going all the way to the left? Negative infinity. Okay? Negative infinity. All right, here's a couple more symbols that we use in interval notation. We use brackets and parentheses. And they mean 2 different things, okay? They mean 2 different things. If you use a bracket, that means you are including the number that it is beside. So, included. If you use a parentheses, that means you are excluding. So, he's excluded. So, a bracket means included, and a parentheses means excluded. This is how I tell my kids to remember. All right, look at that little bracket. He's got his little arms out. He's like trying to include you in his group, okay? Whereas this guy right here, this is the 5th grade boy who the teacher made stand by that girl, and we all know that boys and girls have cooties in that grade, right? And so is he trying to include that girl? No, she's standing over here, and he's trying to stand as far away from her as he can. So he's like swerving like that. Okay? So included, excluded. Now, what about if you were looking at this on a number line? Think about a number line. If I want to include that number in my answer, do I fill the dot in or do I leave it hollow? Does a solid dot mean included or excluded? A solid dot means that answer goes, that number goes with the answer. A hollow dot means that number does not go with the answer. Okay? What about greater than or less than signs? What's this one up here gonna look like? Yeah, this one's gonna be either less than or equal to or greater than or equal to. All right, what's the one underneath it gonna be? Yeah, it's not gonna have the line under it, okay? All right, so this one down here, he's just gonna be less than or greater than. All right, everybody got it? One more thing that you need to know. These two guys right here, these two guys, never included. Which means that you're always going to use what? Parentheses. Included. Think about this. If someone never ever stops, can you include them? No. Think about a little person in the second grade or a kindergartner. Oh my word, have you ever watched kindergartners on the playground? They're like chickens, okay? They never stop. Do they talk? No, they don't talk because they're too busy running around trying to get rid of all that extra energy, okay? So, doesn't ever stop, all right? This never stops, so he's never included. All right, so that's, one more thing. One more thing. This is a rule. The smallest number goes on the left. Kind of logical, right? Smallest number goes on the left. So that's everything that you need to know about interval notation. All right? I'll show you how to use it in just a second. Okay, so the next thing we're going to learn is what's called proper, P-R-O-P-E-R, set notation. Okay, proper set notation. So these are some things about proper set notation. First of all, proper set notation will always be contained in what's called braces. I know you don't like to draw them. You don't have to tell me. Everybody says, oh, I hate to draw those things. Well, I can't do these. Just do the best you can. Okay? They're always contained in braces. Okay, so underneath that, here's what I want you to do. I want you to draw a little C like this on your paper. Just a C, kind of like a half of a circle. And then I want you to put a line in the middle of it.
Oh, that number.
Now what does it look like? An E. It means is an element of. Okay? It means is an element of. You are an element of PreAPalg2 4th period. Okay? You are also an element of Little Cypress Mauriceville High School. All right? So that just means he's a member of that. Here's another one. A double barred R. Do you know what that means? That's the real numbers. Like we wrote the other day on our answer, we wrote all real numbers. Well, now we would write, it was an element of the R, the real numbers. Okay? Now the next thing, I tend to want to show you only one way, but I'm going to go ahead and show you both ways. Because if you got an older book, it might be written the older way. So, the older way. Back when I was in school, this is the way they did it. A double barred N. Okay? A double barred N. And that was the integers. Alright? I always tell my kids, you can always remember it because it's a math people. Are we good at spelling? No, we're not good at spelling, okay? And so someone said, well, what are we gonna call the integers? And someone said, oh, I know, let's call it n, because it starts with an n. And it doesn't really, but it sounds like it does, okay? But then, I guess they got offended, okay, because everybody gets offended now. Then, now they're making it a z, okay? They're making it a double barred z.
That's better.
So, I do it both ways, you know, because this is the way I actually learned it, but now we have to do it this way because some of the books use the z. And these are the integers. Okay? All right, here's another one. Just a line. Just a line. Or you can write a little colon. But both of these things mean such that. They mean the words such that. We're going to use all of these, okay? But I'm going to give you a few more that you see sometimes. Sometimes you'll see a little dots in a triangle, and that just means the word therefore. This is all proper set notation. Okay, therefore. Sometimes you'll see this. Whenever I write it, a lot of times the kids will be like, you misspelled if. And I'm like, no, I didn't. Okay, because this means if and only if. Okay? One more. This
Okay.
and this mean the same thing. What do they mean?
No solution.
That's exactly right. No solution, or sometimes people call it the null set. Okay? No solution, or sometimes people call it the null set. All right, so here's what I want to do. I want to work 3 problems that are exactly like on this worksheet that I want you guys to do, that I said was could be an easy 100. But like I'm telling y'all, listen, I'm telling you, when you do one problem, ask your neighbor, say, hey, does your number 1 look like this? Okay? And see if they're not alike, then make sure one of you's wrong, or it could be both of you, but. All right, so we're gonna have 4 little columns, all right? So the first one is going to be proper set. What does it look like when it's written in proper set? Okay, the second thing, this is my least favorite one, is called verbal. And that's when we have to write it out in words. Like if you read this proper set, that's what you would write down here. Okay? If I read it across and told you what it said, then you would write those words down here. The next thing is going to be a number line. And that's actually going to be a graphical representation. And the last thing is going to be interval notation. And what you're going to find is that this is going to become your most favorite way of writing stuff, because it's very straightforward, okay? It's very easy just to look at it and go, oh, this is what you're talking about. All right, so let's do, now this is the way it is on your worksheet. There are 4 blanks. Actually, on your worksheet, there's only 3, because one of them I'm going to give to you, and then you have to fill in the other ones, okay? So the first one, I'm going to give you the proper set, because we have not done anything in proper set yet. All right, so it has to be in braces. So I'll start off with a brace, and then whatever variable you're talking about, you put that variable. So this is what it says. Any x such that x is greater than or equal to -2. That is proper set notation. It's proper set, guys, just because it has braces and it has this. Any x such that. All right? So verbal, we're just going to write that down. Any x, and you have to write this, comma, such that greater than or equal to. Greater than or equal to, and I'll let you write the number, -2. All right, everybody okay so far? Okay, so this is new. I mean, you've seen inequalities, so all we did was take the inequality, we put it in braces, and in front of it we put any x such that. Put it in braces. Okay, now we're gonna put it on a number line, so I'm gonna draw a number line. All right, I know the -2 has to be on my number line, and I like for a 1 positive to be on there. Okay? Now, I'm gonna circle the -2. Do I fill it in?
No, because it doesn't have a line. Oh, it does have a line under it.
That's exactly right. It has a line under it. Remember up here when we did that? When we said that's a solid dot, okay? So yes, if it has a line under it, then that means that that number is included in my solution.
Mhm.
If it doesn't have a line under it, you leave it hollow. He is not included. Are you with me?
Yes.
Okay, and then we go back and we read this, and it says x is greater than -2. Greater than goes to the right, and less than goes to the left. Okay, so I'm gonna go up here and go to the right. Any number to the right. I'm not gonna do it on my number line, because that makes it hard for people to see. But this, you look at it and you go, oh, okay. -2, and any number bigger than that. That's x is greater than or equal to -2. You agree? Okay, so now let's do interval notation. Watch how I do interval notation. It's extremely easy from a number line, so that's why I make you draw a number line. I start with the smallest number. What is the smallest number on this number line? -2. Is that included or excluded? How do you know it's included? Because it's a solid circle and it has this line under it, right?
Yeah.
Both of those. How do you include something in interval notation? A bracket. Got his little arms out in my hug. Okay? And then it goes an arrow all the way to the right. What is that?
Smallest.
Infinity.
Positive infinity. What do you put by infinities?
Parentheses.
Yes, look right there. Never included, always using parentheses. Okay, now look at this. This says x is greater than or equal to -2. Okay, but look at this, y'all. This says, hey man, you can use any number that you want to. From -2 included, all the way to positive infinity. Okay? Let's do another one. We're gonna do 3 of these, okay? Here's number 2.
I'm no longer like this.
All right, number 2, I'm gonna do this one. Negative infinity to 3, excluded. Sometimes they'll say negative infinity to 3, exclusive.
Excluded is either less than or greater than. There's no.
Yes, that's exactly right.
So, know that.
Okay, so I'm gonna do the number line first, okay? So what number am I gonna circle? A 3, but that's the only number I got. Huh.
No, I mean,
Okay, so I'm gonna circle him. Do I fill him in?
no.
No, because he's excluded, all right? And then I'm going all the way to negative infinity. Which way is that?
To the right. I mean, not to the right, to the left.
To the left, yeah. So he goes over here. So that's what my number line looks like. Okay? Let's jump over here and put it in proper set notation. What does it start with? A brace.
I mean, yeah.
A brace is pretty, okay, and a bracket is square. All right, so a brace, my variable, x, any x, such that x is what? What does this say? X is what?
Less, I mean,
Yes,
yeah, less than.
less than 3.
Less than 2.
And then we write it right here where it says any x such that x is less than 3. All right, one more. This time, I'm going to give you this one. Okay, now think about this. Think about this. This is, this one would be. This one would be the x's that are greater than or equal to negative 3 and what?
And
Less than 4. Okay?
it's a
This
triple one.
it is a together one. It is an and statement, all right? So this is the x's that are greater than or equal to negative 3 and less than 4. All right? Now watch how easy this is going to be to write in interval notation. What's the smallest number your x can be?
Negative 3.
Is it included or excluded?
Included.
All the way up until you get to what?
4.
4, included or excluded?
Excluded. Whoa. Hey, man.
Do you see how easy that is? Okay, look what this says. He says, hey man, you can pick any number that you want to, as long as it's between negative 3 inclusive and 4 exclusive. Okay, you can pick 0, negative 1.2, 3.9. You see what I'm saying? All those numbers, as long as it's between negative 3 and 4, I can include the negative 3, but I can't include the 4. All right, so let's do it in proper set. So I'll put my little brace, and I'll put any x such that, and then I'm gonna write it. Now this is obviously an and statement. An or statement would not look like this, guys. And statements 99% of the time look like this. What's in between two numbers? Because it's like you graphed two things. I'm gonna show you what they are, okay? Look what this says. I want any x that's between these two numbers. Do you see it? Any x that's between these two numbers. So I'm gonna put my x in the middle. I'm always going to point my arrows to the left. If you point your arrows to the left, the smallest number will go on the left and the biggest number will go on the right. Okay? Notice that this one is included, so I'm going to need a little line under this guy. Okay? Now watch what it says. It says, don't just forget about this and read from the variable. X is greater than or equal to what? Negative 3. Over here. X is less than what? 4. And close that little brace off. When we write the verbal of it, the most important word that I'm looking for is that word and. That is an and statement. Okay? It has to have the word and. So it's going to be any x such that x is greater than or equal to. Very good. Or equal to what? Negative 3. And less than what? 4. And less than 4. Okay? I'm looking for this word right here, guys. Alright, so now I want to go back, and then I'm going to pass out your worksheets, okay? I want to go back and I want to do all of these. I want to make sure we know how to do them, okay? Are you with me?
Sure.
All right, so here's the first one. Watch this, okay? And the reason I'm gonna do this is because I know some of y'all went and solved those problems on that worksheet, and you're like, oh, dang, I didn't put that in proper set. Because we're gonna change the directions and make it say proper set. So look what you have to do. Watch up here. See, there's my answer. I'm gonna put it in proper set. I'm gonna open up a brace, write any X such that, and close a brace. Boom, it's in proper set. I didn't have to rewrite it. I didn't have to do anything fancy, okay? Now, it doesn't tell you to put it on a number line, but I'm gonna tell you this. If you will put it in a number line, even if you just jot it out to the side, it will be a whole lot easier to write it in interval notation, okay? So I am gonna put mine on a number line. I'm going to 0, 1. I'm gonna circle 2. Am I gonna fill it in? Yes or no?
No.
No. I'm gonna read from the variable. Always read from your X, guys, even if your X is on what you would say the wrong side. It's still, if you read it backwards, it'll be okay. All right? X is greater than 2, and greater than goes which way? To the right. Now, watch how easy this guy is to put in interval notation. What is the smallest number that's included in my solution?
-1.
No, -1 is not included in my solution.
Oh, 2.
2, okay? Is it included or excluded? Excluded, it's not filled in, so that's a parentheses. And then it goes all the way to
Infinity.
positive infinity. Very good. And you don't have to put the plus sign there. You don't have to. You can, but if it's negative infinity, you do have to put the negative sign. All right, you want to do this one?
No.
Let's make it proper set. Boom.
Oh, got it right.
Okay? Let's put it on the number line. I'm gonna circle -6. Did y'all fill it in? Yes, it has a line under it, so it is included in my graph. X is greater than, and greater than goes to the right. What does interval notation look like? Bracket? Yes, -6, comma, what? Positive infinity. Very good, and a parentheses. All right, everybody okay? All right, let's go down here. I'm gonna do these two really quick. This one's different, so I wanna make sure I do that one. This one, we've done one like it. So we'll just put it in proper set, any X such that, and we'll close off that little brace. If you put him on a number line, y'all look, all you wanna do, all you wanna do is make sure that you circle these two numbers. Here's what you have to be really careful with. You'll lose points for this, so be careful. I'm gonna circle the 1 and I'm gonna circle the 4. The 4 is filled in. Okay? If you read from the variable back to the 1, it says X is greater than 1. X is greater than 1. Greater than goes to the right. Do not put an arrow on it. If you put an arrow on it, you are wrong. Because what does an arrow say? It keeps going, and it doesn't keep going.
Like box.
That's exactly right. He stops at 4. He's greater than 1, and he's less than or equal to 4. So then you could read this other way. X is less than 4, and less than goes to the left. So an and statement is really, what happens is that you graph this right here, and then you graph this right here, and you take what they have in common, okay? And when you take what they have in common, that's most of the time what's between them, and that's an and statement. In interval notation, he's gonna go from what? 1 exclusive to
4.
very good, 4 inclusive. Okay, so this last one right here, I'm just gonna do the exact exact same thing. Open up a brace, any X such that, and close up my brace. This is proper set. But look what an or statement, y'all, when I say an or statement looks like this, I mean that most of the time it does. And I'm talking like 99% of the time it does, okay? So I'm gonna graph this, and then I'm gonna graph this. So, -1, 0, 1. Here's my 2. I'm gonna circle it. Do I fill it in?
Yes.
Yes. Reading, it says X is less than, and a less than goes to the left. All right? 3, 4, 5, 6. I circle 6. Do I fill it in?
Yes.
Yes. He says X is greater than 6, and greater than goes to the right. All right, look at the difference. And statement, or statement. And statement, or statement. If I graph something and they say it's an and statement and it looks like this, I'm gonna go back and check and see did I make a mistake, okay? They most of the time look like this. What does this one look like when you write it in interval? What's the first thing that you come to on your graph? Negative infinity. And what goes beside it?
2.
What goes on the left of it?
Oh,
Parentheses, right? Comma, all the way up until what? 2. And what about that 2? What is he? He's included. And then you have to use a U here, but don't put a stem on it. It doesn't have a stem, okay? It's just a U. And then it goes from what? 6 included all the way to positive infinity. Never included. Okay, so I want to talk about 2 things, and then we're going to do our worksheets. Okay, I'm going to pass these easy ones out, and I want you to do them. So, an or statement. What if I give you an or statement? Now, show me with your hands, what do or statements normally look like on a number line?
They have
They're like, yeah, they're like this right here.
Yeah,
They're going different directions, okay? What if I gave you an or statement and I said, ooh, he's a weirdo, okay? And he ended up looking like this.
Then it would be.
They crossed each other. Instead of them being apart and going out, because really, all we did on our or statement right here was we just graphed this guy and we just shoved them together. It's just one graph, right?
Mm-hmm.
So now we shove it together and this is what it looks like. What's my solution?
It would be no solution. I don't know, actually, never mind. I don't know. Oh, wait, no, I know. No, I know.
Yes, from negative infinity to positive infinity. That's what you started to say first, right? Right? From negative infinity to positive infinity. When you shove it together, it just goes all the way across there. So what does that mean? That means all real numbers. What does that look like in proper set notation? Any x such that x is an element of the reals. Oh, okay. Now, did I start my proper set off any different than what we always have? No. Braces, any x such that. Such that what? X can be any number in the world? Well, that means he's an element of, remember when we wrote this stuff right here? Is an element of the real numbers, the double barred R's. Okay? What if I gave you an and statement, or what if you ended up with an and statement, and he was weird also? Most of them don't look like this, but you ended up with an and statement, and when you graphed it, he looks like this.
I don't know
An
which.
and statement, remember how we graphed our and statement right here? It's what they have in common. This one right here goes like this, and this one right here goes like that.
It would
What
be,
do they have in common between those two?
it would be infinity.
What do they have in common? Nothing. They don't have anything in common. What's on this graph and this graph?
No solution.
There you go. Okay? All right. Just some weird ones. Is this gonna happen very often?
No.
No. Not very often. All right, so I'm gonna pass out your worksheets, and I want you to get started on these right now, okay? And then while you're working on these, I will pass out 3 and 4.